So in Laplace transform, we completed definition as well as problems, right? So system related, how to find the transfer function and all those are also we have completed. So try to solve that problem in the previous lecture, whatever I mentioned, try to solve that problem. So now moving on to inverse Laplace transform concept, because properties already we completed and how to use those properties in finding the Laplace transform phase for the given different types of input signals, isn't it? And initial value, finding initial value, finding final value, all these concepts we covered in previous lectures. So we are left with only inverse Laplace transform concept. Okay, so let us complete that concept also related to Laplace transform. Inverse Laplace transform. You write the complete name, inverse Laplace transform. So x of t, its Laplace transform pair is represented using x of s. And inverse Laplace transform is applied on S domain function. Then x of t is original input time domain function we will get by applying inverse Laplace transform. Okay. So in case of Fourier transform, how did we represent x of t? Fourier transform was x of omega, and x of omega is Fourier transform of x of t. And what was the formula we had there? Minus infinity to infinity signal multiplied with kernel dt. Similarly, to retrieve our original time domain function, we have inverse Fourier transform, which is applied on transformed function. And what was the formula we have there? 1 by 2 pi minus infinity to infinity signal multiplied with j omega t d omega. Okay. Now using this, similarly we have x of t also in case of, this is a concept related to Fourier transform, right? In the same manner, x of t is also nothing but inverse Laplace transform of S domain function. Okay. So we have the formula for inverse Fourier transform. Using that, we can also apply that inverse formula to Laplace transform also. Okay. Okay, let us try to write the formula first for inverse Laplace transform. Compare this. Let us put it again. Square box, and that means I'm going to use that now. X of t. Now compare this. What we have is S is a variable which is represented as sigma plus j omega. What about ds? Sigma is a constant, 0 plus j d omega. So what is d omega now? ds by j, isn't it? So now here x of t inverse, just analogy between Fourier transform and inverse Laplace transform and inverse Fourier transform. Inverse Laplace transform of x of s equal to 1 by 2 pi. And what are the values of these infinity values are for omega variable, right? Minus infinity to plus infinity. Here these are the limits for omega. So here we want limits for s. What is the s? We have sigma plus j. What is omega here? Minus infinity. So minus infinity sigma plus j omega infinity. Omega value is minus infinity. So S values are sigma plus j minus infinity, sigma plus j infinity. Instead of x of omega, what I have to write? X of s I have to write, and s equal to j omega st. In place of d omega, what I have to write? ds by j. So here, if you see, directly I can give you the inverse Laplace transform formula, but how that has come means based on this inverse Fourier transform only. For that reason, I'm explaining all these things. So here, x of t inverse Laplace transform of x of s. You can find this formula in any standard textbook. 1 by 2 pi j, 1 by 2 pi j integration sigma minus j infinity to sigma plus j infinity x of s into e power st dt. This is the inverse Laplace transform formula we have. Okay, how this has come means based on this only, inverse Fourier transform formula only. Because d omega equal to ds by j. Here I have substituted ds by j 1 by 2 pi j. X of s, s equal to j omega. Then only we can convert Fourier transform to Laplace transform. Okay, x of s e power st dt. Here limits are for omega variable. What are the limits? Sorry, I have written here dt. This is ds. This is ds. Please correct it. I'm sorry. ds. These are the limit. Omega is varying from minus infinity to infinity. So s equal to sigma plus j omega we have. So s limits are sigma plus j omega. Omega is minus infinity here, plus infinity. So this is a standard formula for inverse Laplace transform. But we are not going to use it in finding inverse Laplace transform calculations. We are going to depend only on partial fractions method. But whatever standard definition is there, just this one inverse Laplace transform formula we have. Okay, please note it down. This formula, put the heading inverse Laplace transform, and small x of t equal to ILT of x of s equal to 1 by 2 pi j sigma minus j infinity to sigma plus j infinity. Infinity corresponding to this omega limits x of s into inverse kernel, reverse kernel into ds. Copied? Shall I go for problems? Okay, I'm clearing the content. Now note down one problem. Find out the inverse Laplace transform. Find out the inverse Laplace transform of x of s equal to 1 by s plus 4 into s minus 2 if the ROC is minus 4 less than real part of s less than 2. And second bit, ROCs are must to find inverse Laplace transform. If it is not mentioned means by default we consider causal signal ROC greater than poles. And third bit, real part of s less than minus 4. Fourth one, two is less than real part of s is less than minus 4. Okay, this is a problem. See here, sometimes the question may be like, find the inverse Laplace transform of x of s equal to. For all possible cases, simply these kind of ROCs may not be given in the problem. For all the possible cases means, first analyze how many poles will be there for the given function. How many poles? Plus 2, minus 4, isn't it? These two are the poles. ROCs will be based on these poles only. First, real part of s greater than maximum of poles. Real part of s less than minimum of poles. And in between two poles. And some case where ROC, common ROC won't be there, isn't it? So maximum of poles, real part of s greater than maximum of poles, one case. Two causal signals less than minimum of two poles is one case. And in between two poles is the ROC. That is one more case. And one more case where no common ROC. These are the possible cases. No common ROC, isn't it? You can observe here in between two poles where maximum pole is here or minimum pole is here. Based on that, common ROC will be there or not, that we need to identify depending on the particular given ROC condition. Common region is there or not. Like this, if these are not given means you have to take all these possible four cases and corresponding inverse Laplace transform is existing or not statement you have to write for each possible case. Okay. Okay. So let us continue with the first problem. First bit. What is the first one? -4 less than 2. Okay. So what is given function first? X of s equal to 1 by s minus 2. First find the partial fractions for this. Try to find partial fractions. So you can go for either comparison method or shortcut method to find the partial fractions for constants. A into s minus 2 plus b into s plus 4 by s plus 4 into s minus 2. Okay. Hope you have copied up to this. I am totally clearing the content. So what we have? Try to find A and B. Now compare numerator s coefficients first, because this we can write it as a plus b into s minus 2a plus 4b. That is in the numerator. Compare numerator s coefficients. Any s coefficient is there this side? No s coefficient is there. So a plus b equal to 0 and a equal to minus b. And what about constant? Constant value is 1. What about constant value here? Minus 2a plus 4b, which is equal to 1. And a equal to minus b if you substitute, plus 2b, a equal to minus b. 6b equal to 1, b equal to 1 by 6. Then what about a? Minus 1 by 6. So we got both a and b values. Correct? So let us substitute now in x of s, and now easily you can find inverse Laplace transform for all given all the four cases. So the given function x of s can be written as 1 by s plus 4 into s minus 2 is written as a by s plus 4, right? A value is, what was the a value we got? Minus 1 by 6 or not?
Yes, ma'am.
Yes, minus 1 by 6 into 1 by s plus 4. B value is 1 by 6 into 1 by s minus 2. Okay. Now in the first one, what is the first condition we have in the ROC? Minus 4 is less than real part of s, nothing but ROC less than 2. Now check out any common ROC is there or not? Let us say minus 4 is here and 2 is here. These are the two poles. Okay, these are the two poles. And real part of s is greater than minus 4. This side. Greater than. Next, what is the other one? Real part of s is less than 2. this side. Yes, there is a common ROC, that is this one. This is our common ROC. Common ROC is existing. So the two cases, possible cases, what is given here? Real part of S is greater than -4. Real part of S is less than 2. Greater than pole value means causal. Less than pole value means non-causal signal we have to select. So what are the two possible causal, non-causal cases we have? E power -at into u of t. What is its Laplace transform? 1 by s plus a, where real part of s is greater than its pole, minus a. And similarly, minus e power at u of minus t. Please refer, this is correct or not? Even this is also having same Laplace transform, but real part of s is less than its pole. Minus at is there, plus at is there. Correct? Minus e power minus at u of minus t. U of plus t means that is corresponding to causal signal. U of minus t means corresponding to negative sided exponential signal. It may be increasing or decreasing. This is decaying positive sided exponential. This is negative sided exponential. Minus e power minus at u of minus t. Laplace transform is 1 by s plus a, where real part of s is less than its pole. Okay. Now in this case, let us continue with this now. X of s, what we have? X of s equal to minus 1 by 6 into 1 by s plus 4 plus 1 by 6 into 1 by s minus 2, right? So here, real part of s is greater than minus 4. S equal to minus 4 is the pole. So for this, causal signal I have to select. And here real part of s is less than 2. 2 is the pole here. For this, real part of s is less than 2 means which signal I have to select? Non-causal signal, anti-causal. Anti-causal signal. Signal I have to select, isn't it? So based on that, I am discussing only for case 1. Continuation. Apply ILT. Inverse Laplace transform. This continuation. X of s inverse Laplace transform is x of t. E power minus at into u of t. Okay. Now see here. Plus 1 by 6. Anti-causal signal means this I have to select. But what is there in place of a here? Minus 2 is there. In place of a, minus 2 if you write here. Minus e power. Minus of minus 2 will change to plus 2. U of minus t. Okay. So our x of t here is minus 1 by 6 into e power minus 4t u of t minus 1 by 6 into e power plus 2t into u of minus t. That is a inverse Laplace transform for the given function in this case. Minus 1 by 6 into e power minus 4t u of t minus 1 by 6 into e power plus 2t u of minus t. Clear? Do you want me to explain any step here? Shall I go for second bit? Please anyone give response. Vaibhav? Manish, Tapan? Understood? Based on ROCs, we have to select whether causal or anti-causal. Here less than 2 means anti here. Generally, the combination of causal and anti-causal is non-causal signal. What we say, the signal is existing only positive side means causal. Only negative side means anti-causal. Positive side, negative side, both sides means non-causal signal. Okay. So most of the times I'm replacing anti-causal with non-causal. Okay. Anti-causal means only negative side. Causal means only positive side. Both the sides means non-causal. Clear?
Ma'am,
Real
part of s for minus e power minus 80, for that we should get minus a, no ma'am.
Yeah, here it is minus a. Sorry, I have written wrong. Pole value is minus a only here, right? S
Yes,
equal to minus a. So real part of s is less than pole. Here I forgot minus. Correct, ma. I'm sorry. Here I forgot. ROC is same. I mean, Laplace transform is same. Only ROC is different. That's why based on ROCs, we have to choose corresponding inverse Laplace transform pairs. Real part of s greater than pole is there means causal signal plus u of t combination we will select. Less than its pole. Here what is a pole? 2. Less than its pole is there means for this kind of function anti-causal form. Minus e power plus 2t u of minus t. Where real part of s is less than plus 2 here. Plus 2 is a pole value here. Okay. Here minus a. Please correct it. I'm sorry. Real part of s is less than its pole. What is the pole value here? S equal to minus a. So here definitely minus a should be there. Am I clear? Still any more doubts? Shall I go for second case? పొద్దున్నే పడుకున్నారా అందరు? No one is giving response. Dilip, Rohit, ఏనా పేరు గుర్తు రావట్లేదు నాకు. రోహిత్ వర్ధన్, నితిన్, Manasa, Meghana, understood, ma?
Yes, ma'am.
Okay, let us go for second one. What is the second case given? Real part of s is greater than 2. Okay. Now see here, what is x of s we have? 1 by 6 into 1 by s plus 4. What is x of s function we have? A value is minus 1 by 6. 1 by s plus 4 plus 1 by 6 into 1 by s minus 2. Right? How many poles we have here? S equal to minus 4 is 1 pole and s equal to minus 2, 2 poles. Real poles are there. Isn't it? Let us try to write the verify the common RBC here. Poles, let us represent them on s equal to plus 2. Again, I did a mistake here. S equal to plus 2 is the pole here. Minus 2, minus 4, plus 2, plus 4. At plus 2, 1 pole is there and minus 4, 1 pole is there. Let us represent the ROC. Now see here. Real part of S is greater than 2. Means this side. Greater than 2. Okay. So what is the maximum of poles here? Minus 4 comma plus 2. So here real part of S is greater than maximum of minus 4 comma 2. That means real part of S is greater than 2. Maximum number in between greater than 2. That is the ROC given. Isn't it? So if real part of S is greater than maximum of pole values means all causal combinations we have to select. All causal signals in time domain. All causal signals we have to select in time domain because real part, this is from the properties of ROC only. Real part of S is greater than maximum of 2 poles means all causal signals we have to select in time domain. Okay. Because real part of S greater than minus 4 means by default the combination will be, this is a common ROC greater than 2 like that. Okay. So whenever real part of S ROC is greater than maximum of all the pole values means in time domain all causal signals only we have to select. Clear? All causal signals means what is the corresponding pair we have? E power minus 80 into u of t. Causal signal plus u of t. What is its Laplace transform? 1 by s plus a. isn't it? 1 by s plus a, where ROC is real part of s greater than its pole. Now tell me what is the inverse Laplace transform for this? All causal signals I have to select. Apply ILT on this. Then x of t equal to minus 1 by 6 into corresponding function e power minus 4t into u of t plus 1 by 6 into, in place of a, what we have? Minus 2 is there here, isn't it? Minus of minus 2. This can be written as s plus of minus 2, isn't it? S minus 2 is there. So in place of a, what we have to write here? E power minus a. In place, plus a is there. Here plus a is there. Plus of minus 2 we have to take in place of a. So this is e power plus 2t into u of t. This is a corresponding inverse Laplace transform in this case. All causal signal combinations, that's it. Clear this case also? Shall I go for next third bit? Quick. Yes? That means all causal signals we have taken means greater than its pole. Like this. In this case, there is common ROC. Common ROC is there. Common ROC is greater than 2. Greater than 2. So that's why common ROC will be there. If both are selected as causal signals, this is a corresponding time domain function. Clear, ma? Shall I go for third case? Still, do you need any explanation over here? Okay. Third one. What is the third bit given? Real part of S is less than minus 4. Nothing but here real part of S is less than. You can observe here how many poles we have? Plus 2 minus 4. Minimum of poles. Real part of S is less than minimum of pole means all anti-causal signals we have to select in time domain. All anti-causal signals in time domain. Okay. All anti-causal signals we have to select in time domain. That means what is the corresponding anti-causal signal time domain function? We have standard reference pair. Laplace transform is 1 by s plus a only, but real part of s is less than minus a. And what is the function we have? Minus 1 by 6 into 1 by s plus 4 plus 1 by 6 into 1 by s plus of minus 2. Okay, apply ILT. Apply inverse Laplace transform. What is x of t? Minus 1 by 6. 1 by s plus a. What is its inverse Laplace transform? E power minus 4t. This is 4. 4t into u of minus t plus 1 by 6 into minus of e power. In place of a, what we have? Minus 2 is there. So that will be changed to now plus 2t u of minus t. This is a corresponding inverse Laplace. If you want, you can simplify minus and plus. That's not a problem. Okay, this is a corresponding inverse Laplace transform. Finally, x of t, you can write it as plus 1 by 6 into e power minus 4t into u of minus t minus 1 by 6 into e power plus 2t into u of minus t. Less than minimum of poles means you can observe here in S plane, how many poles we have? Minus 4, 2. Less than the 2 pole values. All anti-causal signals means less than. Less means this side. And here also less. There is a common ROC. Real part of S is less than minus 4. That is minimum of poles. Hence, all anti-causal signals we have to select in this case. Clear? Next step. What is the last case given? In between 2 poles we have completed. Greater than maximum pole, less than minimum pole also we have completed. And the last one is third one, fourth one. See here. 2 is less than, real part of S is less than minus 4. If you observe here, what are the 2 cases we have? less than minus 4 and real part of S is greater than 2. That means sometimes you may wrongly go with real part of S is less than minus 4. Anti-causal we will select corresponding to this pole. Here causal signal we may select. But first of all, you have to observe whether ROC is in between two poles or greater than maximum pole or less than minimum pole. This is in between two poles. So common ROC is there or not? Definitely we have to check that first. What is the given function we have? Minus 1 by 6 into 1 by S plus 4 plus 1 by 6 into 1 by S minus 2. Total how many poles we are having? S equal to minus 4 and plus 2. So minus 4 will be here, 2 will be here. Draw lines and observe the ROC here. Real part of S less than minus 4. This side less than minus 4. And real part of S is greater than 2. Greater than 2 this side. Any common ROC is there? No common ROC. Hence, ILT does not exist for this case. Like that we have to write. So wrongly we should not select like this. So this is not a valid function. There is no connected ROC. Connected ROC is not there. Proper region of convergence is not there here. Common ROC is not there for these two functions. Hence inverse Laplace transform does not exist for this case. So blind ga manaki greater less than minus 4 anti whether common ROC is there or not, we need to check it first. Okay. So in between two poles means definitely common ROC must be there. Greater than maximum of all the poles means all causal signals we have to select. Less than minimum of all poles means all anti-causal signals we have to select. Non-causal means in between two poles the ROC should be. Okay. So this is a procedure to find inverse Laplace transform. Mostly this kind of functions will be given. You have to do the partial fractions first. Partial fractions you have to find. After finding the partial fractions only, we can find inverse Laplace transform. Clear? This is a problem. So as I already mentioned, if ROCs are not given based on poles, you have to take 4 cases. If 2 poles means definitely 4 cases will be there. Greater than maximum of pole, less than minimum of pole, in between 2 poles, and without any common ROC, like this 4th case. Okay. So hope this is clear. I'm clearing all the contents. So just last one, try to solve this, giving this as a homework problem. Find inverse Laplace transform. Find all possible, please write here. Find all possible inverse Laplace transform for the function, find all possible inverse Laplace transform for the function x of s equal to 1 by s plus 1 into s plus 2. Find all the possible inverse Laplace transform for the function. So here ROCs are not mentioned. Those ROC cases are all possible combinations. Find all possible inverse Laplace transforms for the function x of s equal to 1 by s plus 1. S plus 2. So first what you have to see here, observe the poles, only real poles are there. Real poles. Real part of s equal to minus 1. S equal to minus 1, s equal to minus 2. What are the all possible cases? ROC. Greater than maximum of poles. Maximum of poles means minus 1, minus 2. That means ROC is greater than minus 1. That means real part of S is greater than minus 1. First combination. What is the second possible case? Real part of S is less than minimum of poles. And third case is in between two poles. Minus 2 to minus 1. If you reverse it, inverse Laplace transform won't be there. Real part of S is less than minus 2. These are the possible 4 cases. Try to find inverse Laplace transform for all these possible cases. If 3 poles are there, 2 more extra combinations will be there. Mostly 2 poles, 4 cases. That is a common problem which is repeated till now. Okay. So try to solve this. If you have any doubts, we will discuss in next lecture. So this is a content related to Laplace transform applications, all the topics we covered, how to find inverse Laplace transform using partial fraction, whether how to choose causal or anti-causal like this. So try to do the problems, whatever I am giving. Okay.